I'm a lecturer in chemical engineering in College of Engineering in Swansea University. I mainly work with water quality, water treatment, drinking and wastewater. I'm looking at a couple of different angles actually, some of them based on industrial requirements, so what we need to fix in the industrial wastewater, and some of them like more hot issues like microplastics. So can we detect them in certain levels, and can we remove them efficiently and of course feasibly. The problem I see with the microplastics, we don't know the extent of their effect or how much we have, because at the moment we don't have a method to see very small particles of microplastics. And then when you get smaller, if you have a plastic, it gets more toxic and more some for other things. So I want to know where it goes and what extent we can look for it. I have some graduate students, they're working on that project. We also teach some water treatment elements in our M-level students, so they are involved in chemical engineering. Well, the problem we have, I think, in especially water quality, if you have a better equipment, you can detect almost anything. And the more you detect, more people start to panic, and it starts a chain reaction. But what I've seen for the last 10 years, we actually don't need that detailed analysis. We can go with the more simple analysis, but we need to know how to use it. So what I'm looking at, I'm not an analytical chemist, I'm looking at how I can improve the sampling methods to modify our own equipment and use it for more detailed analysis. So using more simple methods to go to more complex results. So that's my approach, because it's a bottomless pit. The more equipment you have, the more data you have, and then at the end there's no end to it. So you keep finding new things. So my approach is, if I can use something more simple and available to detect something more complicated or complex. To add to that, I worked with Southern Nevada Water Authority before in Las Vegas, in Nevada. And I worked very specifically on pharmaceuticals and personal care products, which we can now detect very small amounts. And that was a very big deal like 5-6 years ago. And it's the same thing. I feel like maybe it's same with the microplastics. It came out so strong. Everybody was so worried and concerned about it, but we didn't know the extent of it, how it affects us. So I think there should be a balance between how much we can detect and how much we should detect to do some regulative decisions. For example, in Qatar, it's a very new country. So I lived there 3 years. I was a senior scientist in Qatar Foundation. Because it's a very new country and they have economic means, so they had the best technology available in the world, and they just brought it and put it there. So because it's not based on their own experience, it's a bit awkward how it works, because something works in France or UK not necessarily works in Qatar. So I think that was more of an experience than technology, that okay, there is no magic solution, and we have to go through like what we have here, what are the conditions we are dealing with in Wales or in England, and how we can adopt the best technologies. But among the places I visited, I think Singapore is one of the most interesting and most relevant for me, because it's a very small city country and their economy is technology based. So what they do, they spend a lot of money and resources on developing technologies for especially water, and then they use it to go around the world and turn it into a business and licensing it. I think that's why, in my opinion, UK is heading or should head in the future, because if we convert the economy to technology based or know-how based, then the value-added economy would be much better, instead of just applying here very small scope and then trying to get by. My opinion. So I think among everywhere I visited, I think Singapore is one of the best examples that we can learn a lot from them. My opinion for UK, which is really established an old country, and most of things are already in place. I think it should have more for the UK water industry, more on technology based, R&D based, developing new technologies or developing new applications, and then going abroad and make it globally available. Sometimes for least developed countries, sometimes for developed countries. I think there's a broad application opportunity for UK to go.